Alright guys, we are gonna be reacting to Inside the Schwerer Gustav. Thank you so much for the support guys. I've been very curious in the last couple of years regarding this big ass tank-ish cannon, I would say. I don't know, you can this is more like like a cannon rather than a tank. Tanks have wheels. Then this one has like a railroad, so interesting. We're gonna react to this again, guys. Make sure you guys subscribe. We're trying to get to that 10,000 subscribers. You guys can help me out with that. Just simply just give it a click with the subscribe button. Let's jump in.
This is the Schwerer Gustav, also known as Dora, the largest piece of artillery ever used in combat. During World War II, it was utilized to destroy Soviet fortifications.
Wow, man, it's crazy.
The weapon was so massive that it required 5 dedicated trains to transport it and more than 4,000 personnel to deploy it. Even preparing a firing position took 6 weeks. The armor-piercing shells made craters large enough to swallow buildings. The high explosive rounds could bury themselves tens of meters into the ground before detonating. We've recreated Dora in detail to show her strength and explain why the gun was not a success for the Germans.
That's what I heard. What's not
My
a
name is
success?
David Webb, and this is Blue Paw Print. The Schwerer Gustav, or Heavy Gustav, was a railway gun engineered by the Krupp Company, led by Gustav Krupp. The weapon's full length when assembled was 155 feet, 2 inches long, roughly the length of 8 M4 Sherman tanks placed end to end.
Wow.
The barrel alone measured 106 feet, 8 inches long. The nominal caliber of the gun was 31.8 inches. The barrel was rifled, and the rifling depth was initially around 0.4 inches, but after continuous firing, the grooves eroded and the overall caliber increased to over 32.2 inches.
Wow.
The width of the carriage was 23 feet 4 inches, which meant the gun needed 2 pairs of parallel rail tracks to stand on. With the barrel lowered in the loading position, the gun's height was 38 feet 1 inch, almost 4 M4 Shermans stacked on top
Man, that's
of
a
each
lot
other.
of resources to build something
The
like
barrel
that.
assembly alone weighed 400 tons, and the total weight of the gun was 1,350 tons, more than a fully loaded passenger train. To move the gun, it had to be broken down into roughly 25 main components. Deployment started with constructing 4 parallel railroad tracks.
Wow.
2 central tracks were for the gun itself, and 2 outer tracks allowed the gantry cranes manufactured by Ardelt Werke to lift and place the major components in place. The sleepers under all 4 tracks were closely spaced and reinforced by iron grids to help absorb the massive recoil when the gun fired. The assembly followed a specific sequence and required around 250 people working at the same time.
Wow.
First, the left and right chassis halves were assembled on 4 5-axle bogies each. This meant the gun moved on 40 axles, or 80 wheels. Once completed, the central connection and mounting piece were installed between the chassis. Then, the gun cradle was fitted onto the mounting. The gun cradle was carried on 2 trunnions positioned between 2 upper carriage beams. After that, a jacket tube for barrel support was set into the cradle, ready to accommodate the barrel. The barrel consisted of 2 main sections,
Man, this is crazy.
joined by a giant threaded coupling nut in the middle.
Imagine the sound of this thing every time that we shoot. Boom. The wave. I mean, your ears will probably explode by hearing something like this. If you don't cover your ears, of course. That's crazy, man.
The rear half of the barrel was encased in the jacket tube. 4 recoil cylinders were arranged in 2 pairs around the cradle to help spread the massive recoil force and reduce the strain on the carriage. Finally, the breech block was moved into place and installed. At the rear, a loading platform was integrated into the carriage. It featured 2 hoists to lift shells and charges, a self-contained power unit to drive all the servicing mechanisms, and a central loading tray that was equipped with a powered rammer. The gun was powered by an onboard diesel-electric generator.
Mm.
To slow the 1,350-ton weapon, railcar handbrakes were installed on the forward ends of the front bogies. Massive jack pads were installed on the carriage. These were lowered before firing to transfer the recoil force directly into the ground and reduce stress on the wheel axles. The jack pads also prevented the gun from horizontal movement during firing.
Oh.
The huge gun fired 2 primary types of shells. The high explosive shell, or Sprengranate, was the lighter of the 2, including all charges. The complete assembly measured 27 feet and 1 inch long, around the length of a classic London double-decker bus. The shell itself was 11 feet and
27 feet?
4 inches long and weighed 10,000.
Jesus Christ, I cannot even picture that.
1,600 pounds. The shell had a steel body. A ballistic cap made from celumen, an aluminum alloy, was mounted at the nose of the shell. The cap provided better aerodynamics, reduced drag, and allowed the shell to fly further. The cap covered the nose fuse at the upper part of the shell. To reduce the risk of a dud shot, a second fuse was added to the base of the shell. The explosive charge consisted of pieces of hexogen and nitroguanidine. The explosive charge weighed approximately 882 pounds. The hexogen was laid around the fuse so that when the fuse detonated, the hexogen exploded first. This triggered the nitroguanidine, which was less sensitive to shock and needed the hexogen to detonate reliably. 3 pairs of driving bands were made from sintered iron and wrapped around the shell, with a single soft iron sealing ring positioned behind them. The bands gripped the rifling or spiral grooves inside the barrel, making the shell spin as it accelerated forward. They also sealed the propellant gases behind the shell. With the maximum powder charge, the shell reached a muzzle velocity of around 2,700 feet per second.
Wow.
Which gave it a maximum range of roughly 29 miles. After impact, the shells produced craters about 39 feet wide and 39 feet deep in packed earth. The armor-piercing shell, or Panzergranate, was heavier and designed for penetration. That's why it was sometimes designated as the concrete-busting shell. The complete assembly measured 22 feet and 3 inches long and weighed 15,700 pounds, almost as much as a P-47D Thunderbolt fighter. It had a similar appearance to the explosive shell, but had a concealed hardened point beneath the ballistic cap. Unlike the explosive shell, it only had a single fuse in the base. This kept the nose structure intact for better penetration of concrete and armor. The explosive content was approximately 441 pounds. Like the high explosive shell, it used hexogen and nitroguanidine, but in smaller amounts. The armor-piercing shell had thicker walls, which left less room inside for explosives. With the maximum powder charge, the shell reached a muzzle velocity of around 2,400 feet per second and a maximum range of approximately 23.6 miles. Test results showed that the shell could penetrate 33 feet of concrete, around 3.3 feet of armor plate, or 23 feet of reinforced concrete. The gun was designed for long-range siege, not direct fire. Both shells had enough range to shoot across the Strait of Gibraltar. They were fired with a propellant charge of good old smokeless powder. The main charge weighed 2,028 pounds and was placed in a steel or brass casing, armed with a percussion primer. Up to 2 additional bagged charges could be added, bringing the total powder load to around 4,080 pounds for armor-piercing shells and around 4,387 pounds for high explosive shells. The gun could fire at angles from roughly 45 degrees up to 65 degrees. For each shot, the crew lowered the barrel down to a near horizontal position of around 10 degrees or less. This allowed the crew to access the breech and load the gun safely. To aim the gun left or right, there was no turret to rotate. Instead, the entire weapon sat on a curved...
Yo, this is crazy, man. This is insane, bro. You know, you had to say the Germans are smart just to come up with something like this.
section of track. 2 diesel-electric locomotives pushed and pulled the gun back and forth along this curve until the barrel pointed at the target. Once the gun was close to its intended position, electric motors on some of the axles made small adjustments. When the gun wasn't moving, the locomotives could also supply electrical power to the weapon. The crew positioned the gun with precision down to about 0.4 inches along the rails. This let them line up the barrel exactly where the firing calculations said it needed to be. The shell and propellant components were hoisted from ammunition cars on the rear tracks up to the loading platform by 2 lifts. The shell was rolled onto the central loading tray and pushed into the chamber by the powered rammer. The bagged charges came next, followed by the cartridge case holding the main charge. This sealed the breech and provided the ignition. Once everything was loaded, the breech was closed and locked. The crew raised the barrel to the firing angle, while the ammunition cars moved away from behind the gun.
Yeah, to avoid recoil, right?
Then the crew withdrew to covered positions at least several hundred meters from the gun before firing.
Yeah.
Once the fire command was given, the firing mechanism was activated remotely. An electrical striker hit the primer in the bottom of the casing and ignited the charge. When the gun fired, the blast was immense. The shockwave shattered windows in buildings several kilometers away.
Wow.
The sound was so loud that it could be heard 22 miles away.
Wow.
Soviet partisans in the surrounding hills thought the Germans were conducting excavation work with explosives. They didn't realize the sound was artillery fire. Once the gun had fired, the crew returned to the gun and the barrel was lowered back to the loading position. The breech was opened and the spent case was pulled out and sent back down on the lift. Observers in a tethered balloon several kilometers from the gun would watch to see where each shell landed. They would then communicate with the gun crew, allowing them to adjust the gun's aim.
What?
Under ideal conditions with a well-drilled crew, the rate of fire was about 1 shot every 19 minutes.
Damn.
In real combat conditions, though, the practical interval stretched to as long as 45 minutes between rounds.
Wow.
Dora's busiest day saw only 16 rounds fired, despite the massive manpower and logistics involved.
Much
This
resources.
was far from the theoretical maximum rate of fire. Recoil damage to the rail bed and firing curve meant the gun sometimes had enforced pauses of days between shoots. Sometimes the force of the shot compacted the ground beneath the rails by 2 to 3 inches, setting the rails lower and requiring realignment before the next firing. Dora was notably used in combat during the German siege of Sevastopol in Crimea on June 1942. One of its targets was the underground ammunition depot at Sukharnaya Balka, designated Weiße Klippen or White Cliffs by the Germans.
Wow.
When correctly matched to a target, the destructive effect was extreme. One round wrecked the pier and entrance, collapsed the overlying ground, destroyed nearby structures, and even capsized a small steamer anchored not far from the blast. Accuracy suffered badly due to barrel wear. After inspection of a worn barrel, the original life estimate of around 300 rounds was revised to just 100 rounds.
Mm.
The gun was extremely expensive, costing approximately 10 million Reichsmarks, equivalent to the cost of 250 15-centimeter heavy field howitzers,
Yeah.
40 Tiger I tanks, or nearly 2,000 V1 flying bombs.
Yep.
While technically impressive, the gun was operationally inefficient. It was slow to deploy and fire, and required huge manpower for a low shot rate and an even lower rate of on-target hits. In Sevastopol, only 10 rounds landed within 225 feet of the target. Besides, it was an impossible task to move 5 trains and spend 6 weeks in preparation unnoticed by the Allies. The gun was designed for a type of warfare that no longer existed by the time it became operational.
Mm. This
Door
was more.
dismantled
So this was more like a World War One kind of mentality, I
and
guess.
never recovered intact. Components were scattered and scrapped after the war.
Wow.
No complete example survives.
Oh.
If you spot any errors or there's something you'd like to add, please let us know in the comments.
And who's gonna be the brave person that can put all these pieces together and just do like a replica? Yo, like, like who can be that person? I mean, they did the ME262 replica, so if there's some fans that they can do something like that, that would be crazy. But do you really want something like this just roaming around? I don't think so. That was intense, intense. Wow. You have to show you that war. People can go crazy and start inventing stuff. Wow. Let me know what you guys think in the comment section below, and let me know if you guys think this was a good idea. First of all, I would like to know. I'll see you in the next one.